Alright, so what is NMAP? NMAP, short for Network Mapper, is a widely used open source tool for network discovery and security auditing. NMAP is designed to scan large networks as well as individual hosts. NMAP is a powerful tool for IT administrators, network engineers, and cybersecurity professionals alike. It allows for comprehensive network inventory, device detection, and security monitoring by identifying the devices on a network, the services available, as well as operating system types and vulnerabilities in the infrastructure. NMAP is originally command line based but has an alternative version that is GUI based called XenMap. So what is NMAP used for? NMAP is used for network inventory by discovering devices on a network, their IP addresses, and any open ports or services they might be running. NMAP can be used for security auditing by identifying open ports and vulnerable services which can potentially expose security holes. NMAP is also used for network mapping by allowing you to map the topology of a network to further understand the layout and how devices are connected. NMAP provides a way to initiate host discovery by detecting what hosts are up on a network. NMAP can even give information about operating systems and service fingerprinting by getting the target machine's OS and identifying what services and service versions are running on the machine. So how does NMAP work? NMAP works in many ways such as host discovery, port scanning, service detection, OS detection, and scriptable vulnerability detection. There are many different ways NMAP can initiate host discovery. Host discovery allows NMAP to find active devices within a specified IP range. NMAP sends various types of packets to determine whether a host is online using methods such as ARP request. NMAP sends ARP requests on Ethernet networks to identify active devices. This is effective on a local network as every device must respond to an ARP request for connectivity. A TCP SYN ping sends a SYN packet, which is the first packet in the TCP three-way handshake, to determine if a port is open. An open port typically responds with a SYN ACK packet. Finally, ICMP echo request, a standard ping request that waits for a response. Alright, so what I have here are 3 virtual machines that I've set up in VirtualBox. I have a standard Windows 10 Edition VM, a Kali Linux VM, and a VM running OpenSense routing software. NMAP comes by default on a Kali Linux machine, which is what I will be using for this demonstration. NMAP has a helpful built-in guide that you can access by typing out nmap-h or nmap-help. For host discovery, let's start with the list scan method. With the list scan, NMAP generates just a list of target IPs or host names without actually sending anything. This is useful for understanding the scope of the scan without actually probing. The -SL option only lists potential targets based on IP range and host name but does not send any packets. I will use the following command to list potential IPs from 192.168.1.1 to 192.168.1.10. As you can see, the following command generated a list of all the IPs ending from 1 to 10. Another way to perform host discovery with NMAP is using the ping scan method. NMAP sends ICMP echo requests or TCP SYN packets to port 443 by default unless there is a port specified. ICMP pings are typically blocked by firewalls, so NMAP may send TCP SYN or TCP ACK packets instead. If a SYN ACK reply is received, the host is considered up. The -SN option disables port scanning and instead performs host discovery to identify a live host. When I enter the following command, NMAP will scan the IP addresses between 192.168.1.1 and 192.168.1.10. With this scan, NMAP has detected hosts that are up with IP addresses of 192.168.1.1, 192.168.1.3, and 192.168.1.5. Next, NMAP can initiate port scanning. Port scanning is one of NMAP's core functionalities. NMAP checks which ports are open on a host to identify the network services available. Different port scanning techniques can include TCP SYN scan. The most common scan, often called half open because it doesn't complete the TCP handshake. NMAP sends a SYN packet and waits for a SYN ACK, indicating an open port. No response typically means the port is filtered or closed. A TCP connect scan. This scan completes the three-way handshake, SYN, SYN ACK, and ACK. It's slower than SYN scans but works when SYN scans are blocked. A UDP scan. A UDP scan sends UDP packets to target ports. If the port is closed, an ICMP port unreachable message is often sent back. Next is XMIS and FIN scans. These scans attempt to bypass some firewalls and intrusion detection systems by using unusual flag combinations. Now that we've discovered some active IP addresses on our local network, we can go ahead and begin port scanning. To do a simple port scan, simply type out NMAP and the IP address. What this will do is NMAP will scan 1,000 of the most common ports on the machine and report back if any of them are open. As you can see from the output, NMAP managed to discover open ports such as port 135, port 139, and port 445. Now I will demonstrate an NMAP scan that looks for open TCP ports by using the ST modifier with the target IP address. As you can see, NMAP managed to find some open TCP ports as well as a MAC address and the manufacturer of the network interface card. Next I will demonstrate a UDP scan with NMAP. Using the -SU modifier and target IP address, NMAP will scan for open UDP ports. As you can see from the resulting UDP scan output, NMAP managed to find open UDP ports 53 and 123. Next is service detection. NMAP probes open ports with data designed to identify the service running on each port and its version. For example, if a web server is detected, NMAP might send an HTTP GET request and analyze the response to determine the exact version of the HTTP server software. This can be helpful for identifying specific vulnerabilities tied to certain software versions. Now I will demonstrate an NMAP command that will scan for open TCP ports and determine what service and service version is running. Using the -SV modifier with the target IP address. As you can see from the following output, NMAP managed to find a couple open TCP ports and what service is running on the ports as well as the version. Next is NMAP's OS detection. NMAP's OS detection uses the TCP IP stack fingerprinting to guess the operating system of a remote device. By analyzing subtle characteristics and responses such as TCP sequence numbers or IP initial time to live values, NMAP compares these with a database of known OS fingerprints to identify the target OS with some degree of accuracy. Now I will demonstrate an NMAP scan that will also report what operating system the target host is using. By using the -O modifier paired with the target IP address, NMAP will be sure to check what operating system is being used on the target. As you can see from the output, this scan gives you general port scan information as well as determining what operating system was running on the target. Next is NMAP scriptable vulnerability detection. NMAP features the NMAP scripting engine, or NSE, allowing it to run various scripts that can automate tasks like version detection, vulnerability detection, and more complex network discovery. Scripts are written in Lua and can detect vulnerabilities based on specific responses. For instance, an NSE script might identify web servers vulnerable to directory traversal attacks or enumerate SMB shares on a Windows system.